Welcome back, everybody. Mr. Sean here. Let's get into set visualization. What does that mean? All right, let's go. All right, so when it comes on to this thing, last time we draw a Venn diagram. Boom. So, I don't know, something in my eye. Anyways, all right, so now we have to kind of understand, how to draw the Venn diagram. We understood that there was an element 9 that was shared in both of the sets. You could find him in both of the sets, right? So the first thing to understand is what's called intersection. Intersection, or and it's written in terms of this, right? So when I'm trying to describe intersection, I'm going to be saying, well, M, that was one of the sets, intersect R. What can you find when both of them were overlapping? So that would have been this guy here, which would have been just a set with the element 9 in there. Okay? Sounds good? Right? So that's the first thing to understand. So intersection has to do with which elements you can find in both of the sets. All right? Now, the next thing we're going to discuss is what's called the union. Now, I like the symbol for union kind of goes hand in hand with the letter itself, U. So the union looks like a U, all right? Now, if I wanted to put the set that is union, so M union R, right? What union tries to do here, it's like saying, for intersection, it's like saying, what are the elements in M and in R? So which element can be found in M and in R, right? And there will be only 9, right? The number 3 can't be found in set R. It can only be found in M, right? So so intersection's more like very rigid. It's like saying you have to meet this criteria and you have to meet this criteria. The first criteria is that you must be found in M. Second criteria that you must be found in R, right? Now, union kind of does something different. He's like saying, give me all of the people them that's in M, or you might find them in R, right? So there's no rigidness here. Once you're in M, you're good. Once you're in R, you're good. If you're in both of them, you're still good, right? So he's very inclusive, right? So then now when I look at M, I'm going to say, well, 3 is there, so put 3. 5 is there, so put 5. Well, 4 is there also, that's in R, right? So 4, then 5, then keep on going. 7, then 11, or 7, then 9. We have to include the intersection too. 9, so 7, 9, 11. So welcome to intersection versus union. Now, when I talk about visualization, what I mean here is when I have 2 sets, visually, I have set, I'm going to make sure you guys are getting used to the different letters. T and Q. People, it don't matter what letter I call it. It's just a letter, right? I have a set that has a group of elements in there. I have another set that have a group of elements in there. If I want to visually show intersection, then I would be drawing it right here. These are the elements that are found in this blue part. Those are the elements that you can find in T and you can find them in Q. That's intersection. Write it down. Then now, union. What did I say for union, everybody? Anybody that can be found in any one of them are applicable for union. So if I was drawing union visually, I want all the people here. Who are those people again? They can be only found in T. So they're called the T only people. They can be only found in set T. Then you have, who else in there? You have the people that can be only found in Q. Those are the set Q only people. Then you have the people that can be found in both. So if you notice here, I have 3 unique types of people. All right? So union would have been all of this shaded. Let's make sure we understand. So let's use an example. Okay, ready? So I'm gonna put down, we have some drivers. So the universal set, drivers. Okay, I have the Audi drivers, and I have the Mercedes drivers. Okay? Now, me, Mr. Sean, well, me now none of them things, but you don't know, always shoot for the stars. So Mr. Sean, he has, I'm going to put down a couple people. Mr. Sean has an Audi and a Mercedes. John Brown, he have a Mercedes. Susie Q, she have an Audi. Yeah? Let's do 2 more people, all right? James, him have a Mercedes. John, no man, we need to balance it. That's too much. James, Kimberly, she have an Audi. That sounds good, everybody? How many people are? We have 5 people. Now, if I was going to draw this visually in a Venn diagram, I have 2 particular groups of people. I have the Audi drivers and I have the Mercedes drivers. You know this draw, it said overlap. There's an intersection. Who we're going to find in this intersection? Who's here? Who's here, people? That's Mr. Sean. I'm the only person that have both types of cars. So you're going to find me in both groups. Yeah? John, him only have a Mercedes. I mean, the Mercedes only group. Mercedes only. Right? Susie Q, she doesn't have the Audi. She has an Audi only. She doesn't have a Mercedes. So she's only in the Audi bubble. James, he's over here. Kimberly, she over here. So I want everybody to understand this. If I wanted to know who drive an Audi and means intersection, means that you have to meet the criteria of this and you have to meet the criteria of this. So then who drives both of them? Well, not just Sean alone, man. So you have a set with just me. Who drive the Audi or drive a Mercedes? That means more everybody. It's either them drive a Audi or they might drive a Mercedes or they might drive both of them. So we have 3 distinct, unique type of people. Sue and Kimberly are the Audi only people. Audi only. John and James, Mercedes only people. I can't spell, but you just stay with me. Then we have the people them that are Audi and Mercedes drivers. They have both of them. Yeah? So I hope everybody understands what's happening there. Okay? Sounds good?